Welcome everyone. The question that is displayed on the screen, that is question number 10 of the set 1 of the CBSE Physics 2025. Out of the 4 options given, in which transition will the emitted photon have the maximum wavelength? And 4 options are given: n equal to 4 to n equal to 3, n equal to 3 to n equal to 2, n equal to 2 to n equal to 1, and n equal to 3 to n equal to 1. Okay, so these 4 options are given. So let us try to learn or try to remember what is theoretical background of it. Bohr's frequency condition basically gives you if there are two energy levels, okay, let us say this is the E2 and let us say this is the E1. Okay, now when the electrons transits from the, if I say E2 is greater, okay, you have to declare it first. If the E2 is greater than E1 is less and the electron is transits from the higher energy level to the lower energy level, then obviously it will emit a photon, okay, of frequency h nu, and obviously that h nu is the difference between these two energy levels, E2 minus E1. Similarly, when the photon is just falls on the electrons at the energy level E1, it just transits from the E1 to E2, okay, then this type of transitions occurs. Okay, so very simply h nu is equal to E2 minus of E1. Okay, E2 minus of E1. Now obviously from this, putting nu equal to c by lambda E2, what is the energy of the electron in the orbit, putting all this, we will get that relation, that is 1 by lambda equal to the Rydberg constant multiplied by the z square, 1 by n2 square minus 1 by n1 square. This formula is basically find it out. Okay, now what will happen? Now let us put the values and let us try to understand in which case the lambda will be greater. At first, let the take the option A, n equal to 4 to n equal to 3. Okay. So obviously for the first option we can say 1 by lambda A, it is r z square, 1 by 3 square minus of 1 by 4 square. So this will become r z square 1 by 9, okay, minus 1 by 16. So it is r z square, 16, 9 is 144. So it is 16 minus of 9, and obviously this is r Rydberg constant multiplied by z square, 7 divided by 144. Next is 1 by lambda b, Rydberg constant, z square, and obviously it is from n equal to 3 to n equal to 2. So it will become the 1 by 2 square minus of 1 by 3 square. So this will become r z square 1 by 4 minus of 1 by 9. So r z square 36 is the LCM. So 9 minus 4, this will become r z square 5 divided by 36. Okay, now what is now option C? N equal to 2 to n equal to 1. Okay, so 1 by lambda to the C. For the option C we have chosen lambda C, Rydberg constant, z square 1 by 1 square minus of 1 by 2 square. So the r z square 1 minus of 1 by 4. So this is r z square 3 by 4. Okay, the last option, that is n equal to 3 to n equal to 1. So 1 lambda d square, 1 by lambda d square equal to r z square 1 by 1 square minus 1 by 3 square. So that is 1 lambda d, sorry, here is no square, 1 by lambda d equal to r z square 1 minus of 1 by 9. So obviously r by z square 8 by 9 we can say. Okay, so if we try to understand which one is greater, so obviously lambda a is to lambda b is to lambda c is to lambda d. Okay, so we can say lambda a can be written as 144 divided by 7. Okay, what is lambda b? Lambda b is 36 divided by 5. What is lambda c? 4 by 3. What is lambda d? Lambda d is 9 by 8. Okay, so in which case the wavelength have the maximum value? Okay, so obviously 144 by 7. Okay, 144 by 7. So in this particular case, what is the value? What is the value of the 144 by 7? 7 2 14. 14. After that 40 is there. So 7 8 40 is there. So not 7 8. It is 2.5 something. Okay. 5 divided by 36. It is we can say 7.2 something. Okay, next is 4 by 3, it is 1.33. Okay, and the 9 by 8 is 8 1 8 8 1 just 1.1 something. So 7.2 is the maximum one. Okay, so you can say the option B will gives you the more wavelength. Thank you all of you.